All right, so here we are at the notes for 1.6 and 1.7 on relations and functions. We'll work our way through this. There's some vocab here. The math I don't think is that complicated, but the vocab is important because it's tough to do these problems without knowing what the words mean. So just pay attention to the highlighted words. Maybe pause the video more often than you normally do. Jot some things down just to make sure that you understand all the words in these two units. So some basic things. Representing a relation. So what is a relation? A relation is really, it's just a set of points, okay? Um, we use coordinates here, so we have to understand the coordinate system. This is called the coordinate plane with the y-axis, the x-axis. The origin is 0, 0. Each point is named by an ordered pair. That's review. Those are things that you guys have some experience with and know. So a set of ordered pairs is what is called a relation. Okay, a relation is a set of ordered pairs. We can illustrate a relation using what's called a mapping. All right, a mapping is this. It's sort of like an oval with a bunch of numbers from what is called the domain, which is the set of x's, and then a circle over here with the set of y's, which is called the range, and then with arrows pointing to which ones they match with. So you'll notice that -2 and -1 both go to 4, so they both get an arrow going to 4, and that is what is called a mapping. All right. So there's different ways to represent a relation. We have a table, a graph, and then a mapping. All right. Pretty simple stuff here as far as expressing. You guys have worked with tables before. You've graphed points before, and then mapping, that's the one new one. And then determine the domain and range of the relation. Well, the domain is listed out like this. The only thing that I would say that I don't like about the way the book labeled the domain is that they should be in numerical order. This, same with range, should be numerical. Okay? The book doesn't do that. They should. All right? Should be in numerical orders. Make sure you write that down. All right? So if we wanted to express -4, this right here as a table, graph, and mapping, what would it look like? We'll go ahead and pause the video, take a second, get yourself a table, a graph, and a mapping. And the graph can just be a sketch, guys. A table, a graph, and a mapping of those points. Pause the video now. Okay, so check yours against mine. Here's my graph. That's pretty self-explanatory. Here's my table. And I can go ahead if I want and write these are the x's and these and y's. You'll notice that my x's are in numerical order. That's good practice to be in. And then here, the mapping, a couple things. One, they're numerical, and two, and they're both numerical. No repeats, okay? No repeat numbers. Okay, so you'll notice the -3 happened twice, but we only listed it once. No repeats, okay? That is just god-awful handwriting there. Okay, and then part B says determine the domain and range. So hopefully for the domain, you got all the x values. So the domain is -4, 0, 3, and 4. And the range is, and again, these are in numerical order also. I can't talk and write at the same time, evidently. -3, 1, and 2. Okay, and that's the domain and range. Easy enough. Let's go back in time a little bit here. All right. So we've done that. The different representations of the same relation below, like we can see, we can list things out as ordered pairs. Here's it as a table, it's a graph, it's a mapping. All those are different ways to list out ordered pairs. Again, I think they need to do a better job here in the book of these should be in order and these should be in order. Okay, numerical order, please. All right, there's the work we just did. Okay. In a relation, the value of the variable that determines the output is called the independent variable. The independent variable is the x. Okay, that's the x. And the dependent variable is the y values, all right? So if we take a look right here, just identifying which one depends on the other, okay? Which one depends on the other. So a couple of examples, and then we get down here to the problem, and we need to decide, well, which one of these depends on the other, all right? So take a look at 2a and 2b. And the easiest way to think of depending on is like, you know, if you have a job and we're talking about how much money you make. Well, the money depends on how much you worked. You know, so if you make $5 an hour, then time would be the independent variable, and the dependent variable would be money. because the amount of money you make depends on how much you work. So take a look at A and B, see if you can get some answers there, and then we'll check them. Take a look at A and B now. Pause the video now. Okay, so in mine, I got the air pressure is the dependent variable, and the temperature is the independent variable because the air pressure depends on the temperature. And here, the water level is dependent on the rain. So that's the dependent variable, and there's the independent variable. Pretty easy stuff here that you guys have done before. Analyzing a graph, we need to be able to look at a graph and say, all right, so based on this, what is going on? So like describe what happens, and we can say, all right, so time is here and distance is here. So someone was riding, and then for a period of time the distance stopped. So maybe they stopped here to rest or to chat, or they wrecked and they fell, or whatever. They stopped, they rode their bike to school, and then this is while they were at school, they weren't traveling at all, and then they rode their bike some more after school. So you need to come up with a description. I'm not going to give you answers to these. We'll talk about these in class. Some sort of description of why the graph looks like this. Pay attention to what is labeled here. Distance and speed aren't the same thing. So this doesn't mean just accelerating the whole time, because that would be crazy. And here it's income. So take a look at these, see if you can come up with an explanation, and we'll talk about these together in class, okay? We'll go ahead and pause the video here, try some of these practice problems, okay? And again, we'll go over these in class also. So pause the video here. We're not done yet. Pause the video here, try some of these practice problems, and then we'll go over them in class. The second part of the notes today is on functions, okay? It's on functions. So we're going to talk about what that is. Again, lots of vocab today, all right? A function is a relationship between input and output. So a function is a relation, but it's a specific kind of relation. In a function, and this is big time, got to know, there is exactly one output for each input. Okay, so for every x, there is only one y, okay? So here's an example of a function as a mapping. Here's an example of a function as a drawing, all right? So let's take a look at identifying some functions. Determine whether or not each relation is a function and explain. Here, for every value of the domain, the x, there is one y. Now granted, 0 and 3 both go to 6. That's okay. It's that we don't have two arrows leaving the 0, okay? They can share the range, but the range can't share the domain. All right. Here we have the domain. This value repeats. Boom. That is not a function. That is just a relation. Okay. What about here? Is this one a function or a relation? Let's see. 2, 3, 3. Boom. As soon as the x repeats, not a function. Okay. As soon as the x repeats, it is not a function. Let's take a look here. So make a table of values showing the relationship. That's pretty easily. We can make a table of values. Determine the domain and range. So we list those out. Write it as a graph. Again, no problem. We can do that. And then state whether the function is discrete or continuous. Discrete or continuous. Let's take a look up here. A graph that consists of points that are not connected, it is discrete. A function that is graphed with a line or a curve, that is continuous. So pretty easy. Discrete, separated, continuous is continuous. It's connected. All right. So let's go down here. We're going to work on these. I'm not going to make the table for you. You can do that on your own. So the table, make the domain and range. Okay, so let's see. The domain and range. The domain here is going to be what? The domain is going to be the bird feeder with 0, 1, 2, 3 coordinates in it, weighing that. So the domain is the 0, 1, 2, and 3. The range is 2.3, 6, that's 9.7, and 13.4. And then you can pretty easily sketch a graph of those. That's no problem. Would this function be discrete or continuous? And this is discrete because these are just points. Okay, these are just points. All right, so this one is discrete. Okay, no problem there. It's just the vocabulary, the math. There's not a whole lot to the math here. There's also something called a vertical line test. And what we're able to do is, I can tell if a function is a function by using, that's blue also, let's use something else. If it passes what's called the vertical line test. So if I can take a vertical line and then move that line across the function, you'll notice that it never touches the blue line more than once. That means it is a function. If I go over here, boom, right there, it touches it twice, that is not a function. Here, kind of a tricky one. The only place they overlap is here, but one of them is open and the other one is closed. So that never overlaps. That is also a function. Okay? So what we want to do is determine, we're going to make a table of values and graph the equation, okay? So we do all that and we end up with something like this, and it's a line, all right? So is the function, or determine if it represents a function. So if we graph 4x equals 8, we make a table of values, all right? So let's see if we made a table right here for this one. When x is 0, well, what do we have? We got nothing, okay? Nothing. No matter what we do, let's say what if x is 1, okay? We have no y value at all, okay? So there is no y value. So x, when we graph this, we literally just get x equals 2, okay? When we solve this, you solve this equation. It's tough to make a table of values here. We get x equals 2. When you graph x equals 2, I'm going to do it right over here on this one. It actually is just a line at x equals 2 right there. Not only is that not a function because it is a vertical line, okay? That is a vertical line, so that is not a function. Here, 4x equals y plus 8. Here we can make a table of values because now we have an x and a y. So if x is 1, y is 4. If x is 2, y is 0. The only thing I need to make a line is 2 points. 2 points make a line. So I can graph this now. We have 1, 4, okay? And we have 2, 0, right? No, not right. What the heck? Guys, sorry. I hope somebody said, what is he doing? That's way off. Whew. Crisis averted. X, Y. When x is 1, y is negative 4. Sorry about that, guys. When x is 2, y is 0. So, better now. All right. We have 2, 0. We have 1, negative 4, so that would be down here. And then this is a line that looks like this, and it's going forever. I'll show you in class how to graph these on your calculator. It's pretty easy. And then we take the vertical line. Is that going to pass the vertical line test? And the answer to that is yes. This one is a function. Okay? Now, representations of a functions, here's the different way: table, mapping, equation, and graph. And the important thing to know is that for every x there is exactly and only one y. There's also something called function notation. The only difference between a regular equation and function notation is this: we use an f of x, okay? That's how we read that. We read that f of x equals 3x minus 8. Now, it doesn't have to be f. It could be g or q or anything else, okay? F of x. And then what we're able to do is we're able to substitute in numbers for the x in the equation. So if we wrote f of 5, which is how you read it, you substitute 5 in the equation and you find out what the output is, okay, what the range value is, all right? So here we have f of x equals negative 4x plus 7. We want to find f of 2. Well, we just plug 2 in. Everywhere you see an x, you put a 2 and you solve. That's it. Not solve, you simplify, okay? So down here, try these on your own, get some answers, and then unpause the video and check them. But you're just going to substitute whatever's in parentheses in for the x. And then over here, we're going to do some operations with those. Try them on your own and then check them against mine. Pause the video now. Okay, so hopefully you got the same answers I got: negative 1, negative 7, and negative 4. If any of those gave you some trouble, let me know in class, and we'll check those problems, make sure everybody's on the same page. A function with a graph that is not a straight line is just called nonlinear. A straight line is linear. Anything else is nonlinear, all right? But we're doing the same thing on these nonlinears that we did on other ones, on the line functions up here. So we're still just substituting in, okay? Substituting in. So I'm telling you that h of t equals negative 16t squared plus that, and so I'm plugging in 4 everywhere I see a t. Here I'm plugging in g everywhere I see a t and then doubling it. So even if it's a letter, we still do the same thing. I know that sounds complicated, but it's not. If you look, what we're doing is everywhere I had a t up here, I'm putting a g down here. And then once I do that, I'm just doubling everything. It's not very complicated at all. Go ahead and try the video, pause it real quick, and get some answers to 5A, B, C, and D, and then unpause and check them. Pause the video now. All right, here's my answers. I got 128, 6t cubed plus 2, negative 250, and negative 56. Okay, if you didn't get the same answers I got, make sure you make a note of it, and when we go over the notes in class, remind me to check that. Here's some practice problems for you to try. I'd really like you to do 1 through, not too much, I don't want to overwhelm you, but I don't think these are too hard, and some of them are yes or no answers. I'd like you to do 1 through 19. I know it sounds like a lot, but again, some of these are really fast and you can probably do them in your head or it's just writing a couple things down. Try those, and then we'll go over anything that you got questions on in class. See you guys next time. Bye.